Me again. Let's finish off the notes on the ratio test for intervals and radius of convergence. So we're on example 2 now in the notes. And here's another example for interval of convergence. So this one says find the interval of convergence for the series. How do I want to angle this here? There we go. Interval of convergence for that series right there. So now I have an alternating series, which is cool. And I want to find the interval of convergence. Doesn't seem so bad. So let's see here. I'm going to move this camera again because my cat keeps messing with it. If I want to find an interval of convergence, that's your first cue to use the ratio test. Almost every time you want an interval of convergence, you want to use the ratio test. Instances where you don't want to is if you right off the bat realize it's geometric. So this one is not, though. I definitely can't do that. So interval of convergence, I am going to do the ratio test. Sorry, keep moving this around. So I want to take the limit as n approaches infinity of a sub n plus 1 times the reciprocal of a sub n, because you're dividing a sub n plus 1 divided by a sub n, which means you can also multiply by the reciprocal. So a sub n plus 1 is negative 1 to the n plus 1, x to the 2 n plus 1. I'm going to run out of room here. Let me just change that. And then I have x to the 2n plus 1. And the last video, I warned you that this was coming where you replace the n plus 1. Technically, it has its own parenthesis because if it has a coefficient, it matters. So there's my limit. Now, what am I supposed to do with that limit? Well, one of the things I'm supposed to do with that limit is realize, wait a second, those bars on the end are absolute value, which means take the sign inside and make sure it's positive. Well, I have some negative ones in there, which means honestly, I am just going to completely eliminate them. I'm not canceling them. I am crossing them out entirely because the absolute value makes them non-existent really. Okay? So those -1 things are now gone because I don't need them. All right. Now, for the rest of it, I'm just going to simplify. So I have the limit as n approaches infinity of x to the 2n plus 2 over 2n plus 2 plus 1, which is 2n plus 3. There's another cat. Well, it's the same cat. Get your cat butt out of the film. Thank you. And then over here, I have 2n plus 1 factorial over x to the 2n. Now to simplify and divide and say x to the 2n plus 2 is 2 exponents higher than x to the 2n. So these are going to divide, leaving an x squared. Okay, so those divided by each other leaves an x squared. Here's the weird one. 2n plus 3 is 2 higher than 2n plus 1. So that means when I do the factorial, this guy is left with its first two terms and the other one is completely gone. Peter, you're killing me, cat. So this is gone and this is left with its two highest terms, which is 2n plus 3, 2n plus 2. And if you're thinking, wait, that didn't make any sense, think of it this way. If I have 2n plus 3 factorial and 2n plus 1 factorial. Let's pretend for a second that n equals 4. If n equals 4, this would be 9 factorial over 11 factorial, which is 9, 8, 7 down to 1, and 11, 10, 9, 8 down to 1. 9 through 1 divides and cancels, leaving just 11 and 10 behind, the highest two numbers. Okay? That's what really happened over here. So, what do I have left in this mess? I really now have the limit as n approaches infinity of x squared over 2n plus 3, 2n plus 2. Now, n is approaching infinity, which means all I really care about is that. So I'm really taking the limit. Sorry for all of the video issues that I'm having. I just don't want to re-record now. What I'm really doing I'll squat down here, is I'm taking the limit of 1 over 2n plus 3 2n plus 2 as n goes to infinity. So that would be 1 over infinity, which goes to 0, which means this ends up being 0 times the absolute value of x squared, which is 0. Now, the ratio test says if L is less than 1, this series converges. Well, if L is less than 1, it is less than 1. No matter what x is, it's going to get multiplied by 0. So my interval of convergence is going to be all real numbers, because what I'm truly trying to figure out is say, you know what? If the 0 times the absolute value of x squared is less than 1, it's always less than 1. This is going to be true for all x values. And if that's true for all x values, that means my interval of convergence is all real numbers. That means my radius of convergence is infinity. Okay? So here is an example of a function whose radius of convergence is infinite and whose interval of convergence is infinite. Now, let's talk about this for a second. On that last one, I had showed you what the function looked like. I want to do that here just because it's a good teachable moment. So if I plug in values for n starting at n equals 0, don't step on the computer. So if I start at n equals 0, I have 1. And if I have n equals 1, this is negative x squared over, when I plug in 1 there, I have 3 factorial. And then this would be plus x to the 4th when n equals 2 over 5 factorial minus x to the 6th over 7 factorial. Now, that looks kind of familiar. I have all evens, but they're divided by a wrong factorial. And the way that I could probably get here is say maybe this is a modification of the sine or cosine function. So I have all of this stuff. Could this possibly be like, let's say, the sine function, but where everything is multiplied by x? Well, no, because then it'd be too high. What if it was maybe the sine function divided by x? Yeah, that might work. Let's give it a shot. The sine function is all the odds. Oh my gosh, OneNote. Between OneNote and the cat, you guys are getting a really interesting video, and I'm just going to let it be the way it is so you guys know, I am a real person just like you, and we all have challenges. Mine just happened to come in, furry form. So back to what I was saying, I think that this function right here, Peter, I think this function is sine x divided by x. Let's give it a shot. So sine x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And if I divided each of those by x, I'd end up with what I have right here. And we said before that sine actually does converge for all x values, and that's what we just found. Is we found that not only does sine converge for all x values, but sine x over x converges for all x values as well. Okay. All right. Number 3 says find the interval of convergence for that next series, and number 4 moves on. I want to stop the video here because I feel like I've gone on long enough with all the technical difficulties that made this longer. One more video. That's it. All right. I hope you enjoyed the chaos that is my house. That is my life.